pressurization system on the A320 normally operates automatically to adjust the cabin altitude and rate of change of altitude to ensure maximum passenger comfort and safety. Pressurized areas are the cockpit, the avionics bay, the cabin, and the cargo compartments. The concept of the system is simple. Air is supplied from the air conditioning packs to the pressurized areas. An outflow valve is used to regulate the amount of air allowed to escape from the pressurized areas. Automatic control of the outflow valve is provided by two cabin pressure controllers. Each controller has an electric motor to move the outflow valve. A controller-motor combination is known as a system. Only one system will operate at any one time, with the other system acting as backup. A third motor is installed for use in the event of both automatic systems failing and requires a manual input to open or close the outflow valve. To avoid excessive cabin differential pressure, safety valves are installed. Let us look at the operation of the outflow valve for an aircraft in cruise and what happens to cabin differential pressure, cabin altitude, and cabin vertical speed. We will start with cabin differential pressure. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin differential pressure will increase. Now let's look at what happens to cabin altitude. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin altitude will descend. We can also see what the cabin is doing by reference to vertical speed. When the outflow valve closes, the cabin altitude will decrease, negative vertical speed. If the outflow valve is fully open, a lot of air is allowed to escape. The cabin pressure will decrease, the cabin altitude will climb, positive vertical speed. The crew can monitor all cabin pressure functions on the ECAM cabin pressure page. Let's look at the information associated with the pressurization system that is presented on the cabin pressure page. The pack indication is displayed green when the associated pack is on. The outflow valve position can be monitored and the system controller in use is shown.
There is a single indication for the safety valves. We will look at how this indication changes later in the module.
The cabin differential pressure, or delta P, shows the difference in PSI between the cabin pressure and external pressure. This differential pressure will be at 0 on the ground and increase as the aircraft climbs. The cabin vertical speed shows the rate of change in feet per minute of cabin altitude. For passenger comfort, the pressurization system will aim to keep this rate of change as small as possible. The cabin altitude is also shown.
The vent, inlet, and outlet indications are associated with the avionics ventilation system and will be discussed later.
On the ECAM cruise page, there are indications of cabin differential pressure, cabin vertical speed, cabin altitude. There is also an indication of cabin vertical speed on the ECAM door page. Note that this indication is only displayed when the aircraft is airborne. On the overhead panel, there is a cabin pressure panel containing controls to operate the pressurization system. Under normal conditions, no pilot action is required on this panel during flight. The pressurization mode select switch has two settings: automatic and manual. The normal position for this switch is lights out. In this position, the pressurization system is in automatic mode.
The landing elevation selector normally remains in the auto position. Landing elevation, which is required by the pressurization system, is then provided by the FMGS based upon elevation of the destination airport. If the landing elevation is not available from the FMGS, then it can be set manually using this selector.
The guarded ditching switch is provided to close all valves below the waterline so that the aircraft can be sealed in the unlikely event of a ditching.
For a better understanding of how the pressurization system works, we will go through a normal flight profile, paying particular attention to the ACAIM indications.
When the aircraft is on the ground before the flight, the outflow valve is fully open. There is no differential pressure and there is no vertical speed. We can also notice that the cabin altitude is indicating the field elevation of the departure airfield. During the takeoff roll, the system controller signals the outflow valve to close slightly in order to pre-pressurize the aircraft. This is to avoid a pressure surge at rotation. At liftoff, the controller initiates the climb phase and cabin altitude varies according to a fixed law, taking into account the actual rate of climb of the aircraft. The outflow valve will move as required to achieve this. Once established in cruise, the cabin altitude and differential pressure will remain steady. The outflow valve will move as required to maintain the cabin altitude. In the example shown, the aircraft is in cruise at 35,000 feet. Notice the values of differential pressure and cabin altitude. During the descent phase, the pressure rate is optimized so that the cabin reaches landing field pressure just prior to landing. Note, for passenger comfort, the automatic function will limit the rate of cabin descent to a maximum of approximately 750 feet per minute. At touchdown, the cabin altitude should be at the airfield elevation, and there should be no differential pressure. To ensure this, just after landing, the outflow valve is fully opened by the system controller. Once the outflow valve is fully open, an automatic changeover of the system controllers occurs in preparation for the next flight. This happens so that both systems are used equally.
Let's now review some failure cases. The caution cabin pressure landing elevation fault is telling you that the pressurization system has, for some reasons, lost the landing elevation data normally supplied by the FMGS. Notice that the landing elevation details on the system page are blank. Read the actions on the engine warning display. In this case, the procedure asks to set the landing field elevation manually with the landing elevation selector.
As soon as the selector is moved from the auto position, the action line on the engine warning display clears, and a manual message appears on the cabin pressure page. The landing elevation value will also indicate the selected value.
To complete this module, let's look at some other abnormal indications. The safety valves prevent the cabin pressure from going too high or too low.
And ECAM caution, cabin pressure safety valve open, is generated, and the safety valve indication on the cabin pressure page changes to amber.